morning, good afternoon, everybody. So this is Philip Patton. I'm the scientific lead at OntoForce, and I would like to explain you a little bit more how we work with biobanking data, health records data, and link that with public data, enrich that with public data. So what I will try to explain to you is, based with a small mock-up data set, how we can bring a number of data sources together. And so we will start with some patient clinical data derived from an electronic health record system. We will also have a small export from a biobank, and we will link that to some lab test results so that we can make a full journey from a patient linking to related samples which are stored in a biobank and the outcome of these test results, which are then annotated or enriched with public data. So very briefly describing, because we will go then immediately into the webinar itself and into the demo, is what does this clinical data contain. So it's a general patient identification, a diagnosed disease, and a link with a sample or eventually more samples. If you think about the biobanking data, it's mainly an identification of the sample, some storage information in a biobank, and potential annotations like a type of a sample, etc. And if you think about the lab test, this is an ID, a specific run of a lab test, a description, some links with the samples which are tested, and also the analytes, what is exactly tested. So how will we work with this? We will integrate the data in a private deployment of DISQOVER. I will explain you what DISQOVER is, and I will maybe first start with briefly giving you an overview of the public version of DISQOVER, and then show you how in such a private deployment you can enrich this internal data, this local data, with public data. So I will switch to my screen here, where you see a local deployment of DISQOVER. I will first give you an overview of what you see here. So in this general search page, or on this general search page, you have a search bar where you can enter a text string or a number of text strings or a Boolean construction, text construction, so that you can start a search. But this search is conducted against a lot of data sources, and we define a number of data types. And what you see here are these circles which represent data types. And the circles which represent a house, this is an icon which can be replaced with an internal icon or a company icon. These data types contain potential internal data. So the rest of the information is public information. How it looks all together, so is you have a list of all data sources. And if I click on this graph, you see an overview of how all these data sources behave, how they are related to each other. So the majority of the data is public data, relevant, less relevant data, related to an electronic health record system from a hospital. So if I highlight what is the contribution in this graph of the internal data, this is what we have here. This hospital electronic health record data, this is the name of my data set. These are all the data types. And so what you can do is you can highlight here the different types we define, and you also see some links with the rest of the network. So it's a partially isolated graph of information, and there are some links with the network. And that's what you see here. There is an embedding with some external data, some public data. So maybe just show you first what we have. We defined disease, gene, hospital, a lab test type, a patient, a sample, and a variant. So let me start with the patient. I just have 4 patients, very minimal general identifier for a patient, a description of a disease, so 4 patients, 4 diseases. If I would have multiple patients, I would be able to filter on these patients. So I can select, for example, all patients with a certain disease. If I would have multiple patients, I would be able to do that. But I can go into the details of this record, and I see here a description of a certain patient and a link to a number of other data types. That's what we call linked data. You see here an identifier of the patient, very lightweight, first name, last name, and age, a birthday, a diagnosed disease. You could extend this in which direction you want. There is also a possibility to add different levels of security so that you can hide first name and last name for certain people, which are not allowed to see the full clinical information and only are allowed to see certain derived information like an ID or a specific ID or a derived age. What is important here is that we can always highlight where the data is coming from. So this is a hospital electronic health record data source. This is this internal data source that I defined. And what is now important is that this data type, so patients, are related to other data types. For example, sample. This single patient is related to a sample, so I can move to another data type, and I see here a visualization of a single sample which is related or which is annotated with a number of filtering possibilities. It's in a certain storage box, which is positioned in a certain location, it's of a certain type, and it has a certain prelevation date. If I link to that sample, I see here a link, I see here the details about this sample, for example, the type of the sample type, the prelevation date, but also a link, for example, to an external document, which is now just a mock-up document like an informed consent, which could be scanned, and also the positioning. What is important here is that I'm jumping from a patient to a sample. If I just check back my patient, I see that the patient was diagnosed with a rare disease, rare immunological disease. It's a pediatric patient. So combined immunodeficiency, severe combined immunodeficiency, is a disease which is, in a certain case, hard to distinguish from other immunological diseases, rare immunological diseases. So the idea of this data set is to demonstrate that a patient record can be linked to a sample, and this sample is further tested in a lab, in a specific lab test. So I link further from the sample, and I see that my sample is tested, but I also see immediately here the variant, the outcome of the test, because it was a next generation sequencing test, and I can click on that to see the details about this test. So I get here my test results, and I see that this lab test has a number of samples, so that's not just a single record, but my lab test is also related to a lab test type, where you see that this was an exome sequencing, targeted resequencing on a number of genes, and I see some details here about this lab test type. So you see there are a number of jumps I can make, but we can make shortcuts if we want. It's just explaining here what are the different data types and how can we link one to another. So I'm just going back to my sample, and what is now the interesting thing, this is still the local data, the internal data. If I click here on this variant, this is an annotation which is an outcome of the lab test, which means that there was a targeted resequencing run conducted with that sample. They detected one variant, but the annotation of that variant is something which can be found in the public space. So what we do here is internal data, sample data, linking to public data. So if I click here on variant, you will see that I jump to a much more rich environment where I can see a single variant here annotated in a specific way with an identifier for the genome build, the chromosome, position, and then a full annotation from this variant. What are the sources where we derive the information from? This is clinical trials. This is ClinVar, and excuse me, DBSNP, but you also see here hospital electronic health record system. This is the link back from a variant to its sample and even the patient. So the interesting thing here is that I can check it's a biomarker for the same disease, severe combined immunodeficiency. That was my ID to try to confirm with the lab test if the diagnosis, the initial diagnosis was correct. I also see that the clinical significance is depicted as pathogenic, so meaning that this variant is plausible as causing this disease. So this is how you can link locally captured information to public data. I will just go one step back and just start again to show how it looks if you take, for example, all patients, and instead of just following a link from a single patient to the samples, I can also modify my dashboard here, and I can add here, for example, additional links, and just show here that the combination of samples or a selection I can make can also link to my samples. So I'm linking from 4 patients to 3 samples. I see the different storages. So take the 2 samples which are stored in this box. You see this. Again, I can add if I want additional links. So I'm just showing how we can configure the dashboarding. And I can see here the link back to my patients, the link back to my variants. My 2 samples are annotated with 1 test and 2 variants. I can see the 2 variants related to my samples. So you see a lot of flexibility in how we can configure the system. It's now rather, let's say, extensive. We can trim this down for specific user roles to have a quick lookup to say, okay, I'm looking for a patient and I want to immediately see the sample. This is possible. This is now the more extensive layout. Maybe just for the sake of an example, if I would integrate from multiple hospitals information, I could also make a distinction and show here that if I have a selection of samples, that a certain patient, for example, is linked to a hospital. So if I follow this link, you will see that I land on, again, public information about a single patient, or about a single hospital, excuse me. So if I click on this, and this is just an example that I took, you see here that we have Ghent University Hospital as an identifier or as a concept to link to. And so this is, in a sense, what we can do with the different data types, making the links. And how does it work? That's something I will go back again. If I go back again to my samples or my patients, every item, every concept that I talked about and that I showed to you is identified with a unique identifier. And we use a persistent, a permanent URI for this. A URI is a uniform resource identifier. It's similar to a solid identifier that you try to reuse, but which also explains where the data is coming from or from which domain the data is coming. For this mock-up data, I just used a prefix here, so it looks a little bit like a URL. If you're not familiar with URIs, I just took a very general prefix as a hospital.org, a certain patient with an identifier. But if I'm now following the path, you will see that every internal item that I defined, so like this sample, has a similar style of identifier. So you see here that a sample has an identifier specifically here defined for this hospital. But the moment I'm following the link to the variant, because this is public data, you will see that the variant, for example, has a number of identifiers. Because this is information coming from the public space, this is information which is derived from public sources where they use certain identifiers. And this is what we produce here. So there are different ways of explaining or identifying this single variant because there are different, for example here, different versions of genome builds which can be used to reference, to link to this variant. So if in this lab test result, this variant is used, this identifier, this URI is used, we can generate an automatic link towards this single item. So this is how it looks. This is how we integrate data. This is how our user interface works. You see there is a lot of flexibility to define different types of information. If I would like to show you a little bit more, for example, show me all the variants of the gene linked to this this variant. So I'm going to a single gene, and I can go back, for example, to the variant. Just looking for the 397 variants which are associated with the gene that I was looking at. So what you get here is a long list of variants, and now you can make a selection, for example, here to show all the variants which are of a certain type. So instead of just showing this as a list, I could modify the dashboard and just look for the type, the property type, and say, okay, I would like to show this as a pie chart. There is no data. It's the wrong type of selection, excuse me. I can show this as a bar chart, for example. No, it's just the wrong type of information I'm selecting here because it's just a list of items which have a link. That's the reason, and excuse me, they have a link as they are defined as a specific type of information and not just numeric, or not just a string of information. So I will take another example to explain to you how I can differently visualize this. So I'm going back to my hospital information, for example, and if I take, for example, this hospital that I took as an example is related to a number of clinical studies, I can show here, for example, different clinical studies which are related. So I have patients related to a hospital related to clinical studies, and I can visualize, for example, the study phases and show this as a pie chart. Again, the remote data is not visualized. I can show, for example, an expert view, another, no, the template is not available. This is because I was using some default sets that I had to double check. But what I want to show you is, if you have certain information available, you can show different ways of representing the data. If I go back, I have my general overview. This is what we have here, and this allows you to define different use cases. So again, this is very general. We can trim down, we can specify per user role subset of the data. Now I would like to jump briefly to how we have integrated the data. So this is showing you the internal system. I will expand a little bit on this. This is showing you the pipeline we have built, the integration pipeline we have built to start to integrate the data in DISQOVER. So what does this show? It shows that we have defined a data source. It shows that we have defined how we would like to integrate the data. So this is like prepared data in a specific format. And then we define a number of what we call data types or canonical types. So we define a lab test, a gene, a diagnosis or disease, a variant, a sample, a hospital or organization, a lab test type, and a patient. What is now specific, you see here add label. This is a component where you specifically define how would you like to identify a lab test. How would you like to label a lab test? So that means that if you have different sources, you can decide what is the preferred label, what is a synonym term, etc., that you would like to use. What is also interesting to show is the following link. I was defining genes, or I was defining variants in these lab tests, and we used a link with what we call federation to the public data we host on another server. So if I click on this, you see how we define with relatively simple definition. It's a certain target class, an electronic health record variant target class. This is defined in a previous step, that we would like to link the URI, the identifier, to this to the public system. And so what happens during running this pipeline, there is a matching, or there is an attempt to match the identifier that I defined in the internal data with the public data, so that you make a dynamic link between what we have here as internal data that could be linked to public data. So how does it work? I can, because it's a very small data set, I can let it run very rapidly again. So if I just execute the pipeline and I would like to do it a little bit more extensive in a debugging mode, you see that the pipeline is running, and I can check in every single step how the pipeline is running. So every step we take to integrate the data can be checked. There is a possibility to have different, so the execution status is a way to define if everything works fine. So everything is green, so everything works fine. Or you can check the component types, and then you have different color codes to distinguish every single step in the process. So this is in a very short demonstration how we can link different data sources, internal data sources to public data. A very short overview of how the process itself works, and that will be part of other webinars to go deeper into this. This is like the first representation of how this works.